Three.
Hello everyone, my name is Ali Park. This is James Morgan, and we have Daniel Bone and Rachel Sabino on our team. We are grade 4. We decided to do the FiScript, and let's tell you a little bit about it.
FiScripts are a useful tool for all sorts of industry, anywhere from professional welders to just your normal DIY person. They're useful in holding stuff together, especially when you're trying to weld parts together. Their locking capability is really useful because you don't have to stand there and hold the pliers. The adjustment of the screw allows you to change where the jaws are going to lock shut. This allows you to be able to use them on various different sizes.
3.
The main component is the long handle, which is pinned to the lower jaw, which is pinned to the short handle, which is pinned both to the buttress and to the release lever. The buttress has a sliding prismatic joint with the long handle. The adjustment screw has a screw joint with the long handle, and the spring is pinned to both the lower jaw and the long handle through a little spur right here. The long handle is the main structural component of the FiScript, so it has to be really strong to withstand the internal forces from the other components. But since it's 1/10 inch thick tool steel, it's plenty strong enough to hold up against any forces. It has screw threads in the back so the adjustment screw can be screwed in and out in order to push the buttress back and forth. And the entire top side is an open slot so that the buttress can slide back and forth, but the back half of it is narrowed so that the buttress can't pull out this way. The whole interior is hollow also, so the buttress can slide back and forth, and so the screw can be inserted by its full length. The pinhole over here allows it to be pinned to the upper jaw, and I use GD&T to control the position of this, because if this pinhole on the one side is misaligned from it on the other side, then the pin would end up slanted, and that would cause undue internal stress. The spring pulls the lower jaw and the handle together to hold the pliers in an open position as long as the handles aren't being squeezed together and as long as the pliers aren't locked shut. The spring was pretty simple. I didn't really have to use GD&T for anything because, like, any significant variations in form would have to be very, very large to cause an issue.
The lower jaw is connected to the long handle, the spring, and the short handle via pin joints. The pin joints allow it to pivot where it's necessary. As you can see here, this is where the location of one of the pin joints. That allows it to pivot to close the jaws. This pin joint allows the short handle to pivot around the lower jaw, which allows it to move the lower handle to translate while this pivots. As you can see here, I use GD&T to tolerance my part. I used a perpendicularity tolerance, a circularity tolerance, and a position tolerance. This ensures that the pin going through it will stay perpendicular to the surface and it won't allow it to move around in the hole. The buttress is connected with a pin joint to the short handle and a prismatic joint to the long handle. The prismatic joint allows it to slide within a groove using this flared end shown right here. The hump shown right here allows the lever to push up against it, unlocking the locked jaws. The translation restriction for the prismatic joint is determined by the bolt that's screwed into the long handle.
Okay, so this is the short handle. The short handle will connect to the lower jaw and the buttress with pin joints still levered. When the short handle is squeezed, the buttress pushes towards the jaw and the lower jaw will pivot close. So as you can see here, this was a pretty complicated part. So what I did was make it into 5 different sections and I swept all the way across. Upon doing the geometric dimensioning tolerancing, I only used the position tolerancing because perpendicularity and circularity were not necessary because it's a surface only. Okay, now this is the release lever. The lever connects to the short handle with a single pin joint. The rotation is around the pin, restricted by the contact with the short handle. When squeezed, the lever will rotate around the pin, pushing the buttress out of the lock position, causing the jaws to become unlocked. Again, this actually wasn't as hard of a part to make. I used a revolve to make this, and I extruded in, and then finally made the geometric tolerances for the holes only, because that is the most essential part to make an art assembly work.
The vice grip has 4 pins that are used to hold everything together. They allow the rotation and translation to work smoothly. I used cylindricity for each of the pins to ensure that they are cylindrical, and so when you put them inside the part, everything moves smoothly. Alright, so I also had the bolt to design. The bolt screws into the long handle, and it allows the user to adjust the width of the jaw opening when locked. This adjustment is used by screwing and unscrewing the bolt and the translation restricted of the prismatic joint between the buttress and the long handle. So for designing this part, it was a little bit difficult because of the teeth on the screw, but once I figured out the major and minor diameter, it was pretty simple using a helical sweep. And also I did no geometric tolerancing for this because since it's a screw, it can go in pretty easily despite some problems. In total, we have designed the vice grip in 11 parts. We used a drill to draw out the center of the rivets to remove all the pins. We then used calipers to measure each part individually. The vice grip is made of tool steel to ensure strength when interacting with other materials. We chose the vice grip because although it only has a few parts, the complexity of the design made it a good challenge. Locking pliers are interesting because lever action is stronger than that of ordinary pliers, so they can exert more force. This tight grip is best when applying torque to an object, and like Daniel said, it's good for welding and DIY projects.
Perfect.